Hi, it's Ryan. This is our introduction to the principle of conservation of energy. The principle of conservation of energy. In other words, you guessed it, POCOE. The principle of conservation of energy is really the first of several conservation laws that we have in physics that we were going to be talking about. And it's simply put that energy can neither be created nor destroyed. It can only be transformed. Energy can neither be created nor destroyed. It can only be transformed. That is the principle of conservation of energy, or what I'll normally refer to as POCOE. So that's its statement. That's the principle itself. We'll give you the mathematical definition. All this says mathematically is that for a closed system, the total energy is constant. And I guess mathematically we don't use exclamation points unless they're factorials. The way that we'll usually write this instead is that the total energy at any one point is always equal to the total energy at any other point for some closed system. And when we start this out, the total energy will always break up into the possible energies it can have, which will be the potential energies plus the kinetic energies. And so this is the mathematical layout that we'll use anytime we want to apply the principle of conservation of energy. And to be honest, anytime you can get away with using POCOE, you should, because it usually shortens up your mathematical requirements. The other principle or theorem that we have to define for you, and it really is just a kind of the fallout of POCOE, and that is the work energy theorem. The work energy theorem. The work energy theorem has a strong and a weak form. We usually will just use the strong form. The strong form for the work energy theorem is that the work on a body is equal to the change in kinetic energy of the body. So this is really what we'll use anytime we can. There is a weak form, and this really comes from POCOE more than anything, but work is equal to the change in potential energy plus the change in kinetic energy. And if you were to break deltas into final minus initials, you could show that this turns into POCOE basically, but the work would be done by some non-conservative force normally. Okay, anyway, that's a little bit much. We'll really be using this anytime we can. The last definition that we have for this one is power. Power. The easiest way to define power is mathematically. Power is defined as work over the time that the work is done. And so that can just equal the change in energy over change in time, but that would make it average power. So when we talk about the horsepower of a car, which is my least favorite unit in our number system, or in our unit system, but when we talk about the horsepower in a car, we're talking about how much energy per second your car can dissipate or use. The unit for power, the unit is 1 joule per second, of course, because it's energy per time. And we give that a name of a watt. 1 watt. So there you have it.